Another interaction between electric current and magnetic field is the law of generator. The law of generator states like this. If a conductor is moving in a magnetic field with a velocity v, then there will be voltage being generated across the conductor. The magnitude of the voltage will be B times L times B. B is the magnetic field density. L is the length of the conductor. B is the velocity. Then the direction of the voltage, in other words, the positive and negative of the voltage, is determined by the right-hand rule. You can have your right hand like in this figure. Thumb, forefinger, and middle finger, they form the three axes, X, Y, and Z. Let your thumb point to the direction of motion, that is to the right. Then the cross means magnetic field into the page. That is where your middle finger is pointing to. Then your middle finger is pointing to the direction of current. That will be upward. Here is the direction of the current through the conductor. Then we know the voltage across the conductor. The top will be positive, the bottom will be negative. And this is the direction of the current through the rail and the conductor. Now let's still look at the example of loudspeakers with current. Loudspeaker with circuit. In the last example, we know by the law of motor, when the current is being fed into the conductor, and the conductor is placed in a magnetic field, then the force will be generated. In this case, the motion is to the right, and the current, let's assume the current is downward. Then let's determine what is the direction of the magnetic field, into the page or out of the page. Then we need the right-hand rule of the law of motor. I will give you 1 minute to figure it out what will be the direction of the magnetic field. If your answer is into the page, then you are correct. We know based on the right-hand rule of the law of motor, the thumb is the direction of the current. Your palm is direction of the force. That means your palm will face to the right and your thumb is pointing downwards. Then all your other fingers will be point to the direction of magnetic field. That is into the page. Then let's figure out if the magnetic field, the direction of the magnetic field is into the page. Then what will be the voltage being generated due to the law of generator? We know the coil is moving to the right in the magnetic field. Then voltage will be generated across the coil. Then what's the direction of the voltage? Let's still use the rule of generator, using the right-hand rule for the law of generator. Then we know thumb is the direction of motion. That will be to the right. Then forefinger is the direction of the magnetic field into the page. Then we know the current being generated due to the law of generator will be pointing to upward. That is the direction of your middle finger. This is the direction I, say IG, then we know the voltage of the coil, the top will be positive, and the bottom will be negative. Then you see it has a different direction from the voltage source. Then the magnitude of this voltage is B times L times the velocity. We know the velocity is x first derivative. Then L is the length of the coil, is 1.26 meter. Then B, magnetic field density, it is 0.5 Tesla. Then we have the voltage of the coil is B times L times velocity. That will be 0.63 times velocity. Then we can apply the law, the Kirchhoff voltage law. We know the Kirchhoff voltage law states that in a closed path, the sum of all voltages is 0. Then let's first change everything into impedance. So for the inductor will be Ls. Then we have this from positive to negative, we have Ri. This one we have Lsi, also from positive to negative. Then we have the voltage due to the law of generator, the voltage across the coil. That will be 0.63 Sx if we apply the Laplace transform. Then for the voltage source, it will be minus VA. This is called voltage law. Then again, we can apply Newton's law based on the law of motor. So we assume the effects of the air can be modeled as if the cone has equivalent mass m and viscous friction coefficient B. This is the cone, m, then F. This is the value we obtained from the last example based on the law of motor. If the current is I, then this term is a friction, B times the velocity. Now, if we take the motion of the cone as output and VA, the voltage source, as input, then we can obtain a transfer function from the voltage to the motion of the cone. To do that, we can use these two equations. We can apply the Laplace transform to the second equation, how m s squared plus b s equal to (0.63) half times x. Then based on these two equations, we assume VA is known, x is unknown, and I is unknown. Again, we have two approaches. One approach, we can replace this I, the current, by x. Then we get the relationship between VA and x. Another approach, Cramer's rule. Have a matrix here. We have I, x, VA, 0. Then we can solve for x. Then we obtain a transfer function from VA to x. This is the transfer function from VA, the voltage, to x, the motion.